This is Jothilatha of BCA department. Let us see the basic concepts of OOPS in Java. Why do we need object-oriented programming? It was developed because limitations were discovered in earlier approaches for programming, such as lack of reusability, maintainability. So fundamental idea of OOPS is to combine a single unit, both data and functions. Such an unit is called object. The object is divided into a number of entities called objects. The data are closely tied, so the function only can operate on it. Communication of the project objects done through functionally. Data of an object can be accessed only by the functions. The picture can clearly explain about the concept of the object. There is an object. Inside the object there is a data and member functions. The object can access the data and also the member functions. What are the characteristics of the OOPS? The programs are divided into objects. It follows bottom-up design. Objects can communicate with each other. New data and functions can be easily added. Functions that operate on data are tied together in data structures. Data is hidden. Emphasis on data rather than procedure. What is meant by bottom-up approach? It may allow unit testing. It promotes code reusing. Reverse top-down approach. Lower level structures are evolved first. Then higher level structures are created. The basic concepts of OOPS. It's an important topic of OOPS concepts. Let us see about all the topic in detail. Objects. Object is nothing but the combination of operation attributes, methods and data. They are runtime entities of an object. For example, they may represent a person, a place or item, whatever it may be. See the picture, there is an object called car. Inside the car there are some data members: model, year of manufacturing and color. Some functions are also embedded: start, move and to stop. When a program is executed, the objects interact by sending messages to one another. For example, customer is an object, account is an object. So customer object can send a message to the account object for requesting some bank balance. Classes. Classes are user-defined data types. It is built-in types of programming language. Objects are variables of class. A class is a collection of objects of similar type. Encapsulation. The picture itself clearly explained the concept of encapsulation. Variables, methods are encapsulated into a tablet like class. The encapsulation is the first pillar of the OOPS concept. It's a process of binding data members, that is variables, properties and member functions, that is methods, into a single unit, and class is the best example of encapsulation. For example, consider a situation. It's a medical store. We go to the medical store and ask some chemist for some medicine. Only the chemist can access the medicine, not us. So this reduces the risk of taking any medicine that is not intended for us. In this example, medicines, it's a member variables. Chemist, it's a member methods. You, external application or piece of code. This picture clearly explains about the encapsulation. In this, private instant variables, private methods, variables, public methods are encapsulated into a class. Encapsulation. Through encapsulation, data is not accessible to the outside world. It solves the problem at the implementation level. So encapsulation means hiding the important features of a class. Exposed part of a class acts like abstraction. Next we are going to see that. Next one is abstraction. It represents the necessary features without including more details or explanations about something. Data abstraction is a programming technique that relies on the separation of interface and implementation. For example, when we press a key on our keyboard, the character appears on the screen. We need not know what exactly works inside, but it is typed on the screen. So this is called as abstraction. One more example, we use the remote control of our TV. We do not bother about how pressing a key in the remote changes the channel on the TV. We just know that pressing a plus volume button will increase the volume. So this is another example of abstraction. Inheritance. The mechanism of deriving a new class from old class is called as inheritance. In Java, the old class is known as base class. The new class is called as derived class. The powerful feature of OOP concept in Java is inheritance. For example, consider a family of 3: mother, father and son. Father is tall and dark, mother is short and fair. So Jack inherits the properties of tallness and fairness from his parents. So it's an inheritance. Inheritance save lot of time and also reduce errors, which in turn increase the quality and productivity. There are different types of inheritance: single, hierarchical, multiple, multi-level. We will explain in detail later. Next one is polymorphism. It's a Greek term which means ability to take more than one form. There are two types of polymorphism: operator overloading, function overloading. Operator overloading means the same operator may behave differently. Function overloading means function may takes two arguments or three arguments. It does different objects. The functions also can be overloaded. Dynamic binding. Binding means link between procedure call and code. Process of a linking of a function called to the actual code. It is also known as late binding. Compiler comes to know the runtime errors. Message passing. Objects communicate with each other, like people are passing the messages. For example, classes product and order. The object of the product class can communicate with the object of the order class by sending a request for placing order. Here one more example: student, faculty, and performance. So they can access all the objects based on the performance. Benefits of OOPS: code can be reused, data are hidden, operators or functions can be overloaded, users can create new data type or user defined data type. Object oriented system can be easily upgraded from small system to large system. Maintenance cost is less, simple to implement. Where are the areas we can apply the OOPS? In real time systems, object oriented database, AI and expert systems, office automation, neural network, and parallel programming. Thank you.